When you eat gluten, a protein found in wheat, barley, and rye, it doesn't immediately wreak havoc on your digestive system like many assume. Within the first 30 minutes, your body begins breaking it down into smaller components using enzymes in your saliva and stomach. This initial digestion continues in the small intestine, where gluten is further dismantled into peptides and amino acids. For most people, these fragments are harmlessly absorbed, providing energy and building materials for your cells. The misconception lies in the belief that gluten universally causes inflammation, but in fact, this reaction is limited to those with specific conditions like celiac disease. Contrary to popular belief, gluten isn't inherently inflammatory. In non-sensitive individuals, gluten peptides are broken down and absorbed without triggering an immune response. Meanwhile, your small intestine is busy absorbing nutrients from your meal, utilizing transport proteins to shuttle digested molecules into your bloodstream. The real issue arises only if your immune system mistakenly identifies gluten as a threat. In such cases, it can lead to inflammation and discomfort, but this is not the norm for the majority. The distinction is crucial. Gluten's impact depends heavily on individual genetic and immune factors, not a universal rule. Within the first 15 minutes of digestion, enzymes like pepsin and trypsin are already breaking gluten into smaller peptide chains. For those without gluten sensitivity, these peptides simply travel through your digestive tract, undergoing further breakdown and assimilation. The myth of gluten's universal harmfulness ignores these efficient processes that most bodies handle seamlessly. It's only in gluten-sensitive individuals that these peptides cause immune cells to misfire, leading to inflammation. For the majority, however, gluten is no more problematic than any other protein, quietly nourishing cells without incident. Gluten's journey through your digestive system begins with saliva enzymes like amylase breaking down starches, but gluten itself remains intact until it reaches the stomach. Here, gastric acid and enzymes such as pepsin start to unravel the protein structure. This process continues in the small intestine, where gluten is broken down into amino acids. These amino acids are absorbed into your bloodstream without fanfare or immune reaction, unless you have a specific sensitivity. This efficient breakdown and absorption process is the norm rather than the exception for most people consuming gluten. The myth that gluten is inherently toxic overlooks the role of enzymes in your digestive system. Within 30 minutes, these enzymes dismantle gluten into peptides that, for the majority, pass harmlessly into your bloodstream. In non-sensitive individuals, this process does not provoke inflammation or discomfort. Instead, these peptides are utilized as a source of energy and protein. The vilification of gluten ignores this seamless digestion that occurs in most people, focusing instead on rare sensitivities. Understanding this distinction is key. Gluten's interaction with most bodies is benign, not harmful or inflammatory. Inside your small intestine, gluten peptides interact with enzymes like tissue transglutaminase, which modifies them. For those with celiac disease, this modification triggers an immune response, but in others, these peptides are absorbed without incident. Intestinal cells transport these peptides into the bloodstream, where they serve as building blocks for proteins. Surprisingly, a study in Gut Microbes, 2022, found that certain beneficial gut bacteria can even help metabolize gluten, reducing its potential to cause discomfort in sensitive individuals. This enzymatic and microbial interplay highlights how gluten is managed effectively by most digestive systems. Within your gut, gluten encounters a vast array of enzymes and microorganisms. Your microbiome, a complex community of bacteria, actually aids in breaking down gluten into harmless amino acids. In healthy individuals, this microbial action supports digestion and nutrient absorption. Research published in the Journal of Clinical Gastroenterology, 2023, shows that specific strains of bacteria can degrade gluten peptides, mitigating any potential inflammatory response. This indicates a symbiotic relationship where your gut microbiota assists in processing gluten, emphasizing the importance of microbial diversity in maintaining digestive health. Gluten's journey doesn't stop with digestion. It influences metabolic processes within your liver as well. Once gluten peptides are absorbed, they reach the liver, which breaks down amino acids into energy and other compounds essential for cellular function. Interestingly, a liver enzyme called glutamate dehydrogenase is involved in converting these amino acids into neurotransmitters. This process highlights how gluten-derived peptides contribute to brain chemistry, not just nutrition. For most people, this conversion is seamless, integrating gluten into broader metabolic pathways without issue. The small intestine features a lining of epithelial cells equipped with tight junctions which control the passage of substances. In healthy individuals, gluten peptides do not disrupt these junctions. However, in celiac disease, these peptides can trigger zonulin release, a protein that temporarily loosens these junctions, leading to increased intestinal permeability. This phenomenon, often called leaky gut, is specific to those with underlying sensitivities. For the majority, the intestinal barrier remains intact, effectively managing gluten peptides without triggering zonulin release or inflammation. As gluten peptides are processed in your body, they do not typically cross the blood-brain barrier. This barrier is a selective filter that protects your brain from potential toxins. In most individuals, gluten peptides remain in the bloodstream, providing necessary nutrients without affecting brain function. However, some research in Neurobiology of Disease, 2023, suggests that in rare cases, certain gluten-derived compounds might influence neurological pathways in sensitive individuals. Nonetheless, for the vast majority, gluten's biochemical footprint stays confined to metabolic and digestive pathways. Consuming gluten in excess generally poses no harm for most people, as your digestive system efficiently manages protein intake. However, a 2021 study in the American Journal of Clinical Nutrition revealed that chronic overconsumption of refined grains, not gluten itself, can lead to obesity and metabolic syndrome. This is due to an imbalance in energy intake versus expenditure, not the gluten protein. Your body stores excess calories as fat, potentially leading to insulin resistance and other health issues. This distinction is crucial. It's the context of your overall diet, not gluten alone, that influences long-term health outcomes. When gluten is absent in your diet due to medical necessity, such as celiac disease, your body adapts over time. Your digestive system adjusts by relying more on other protein sources to meet nutritional needs. A 2023 review in Advances in Nutrition showed that gluten-free diets can lead to deficiencies in fiber, iron, and B vitamins, which are often found in fortified and whole grain products. This absence can alter your gut microbiome, reducing beneficial bacteria diversity and impacting overall gut health. This adaptation showcases the delicate balance your body maintains to ensure its nutritional requirements are met. Long-term gluten exposure in sensitive individuals can lead to chronic inflammation and intestinal damage. In such cases, the immune system's constant activation against gluten peptides can cause villus atrophy, where intestinal villi are eroded, reducing nutrient absorption. This kind of damage can lead to malabsorption syndromes and increase the risk of associated disorders, such as osteoporosis and anemia. A 2023 study in gastroenterology found a correlation between untreated celiac disease and increased cardiovascular risk. These outcomes highlight the importance of accurate diagnosis and management in those genuinely affected by gluten sensitivity. Food companies capitalize on gluten-free trends, often neglecting that many gluten-free products contain higher levels of sugar and fat. A 2022 analysis in food chemistry revealed that gluten-free breads often have increased calorie content, potentially leading to weight gain if not consumed mindfully. This nutritional trade-off underscores the importance of understanding product labels and the ingredients they contain. For most people, gluten-free does not equate to healthier, as unnecessary avoidance may lead to nutritional imbalances. This market-driven misconception highlights the need for informed dietary choices based on individual health needs rather than trends. The most surprising truth about gluten is its historical role in human evolution. Archaeological evidence suggests that early humans consumed wild grains over 30,000 years ago, long before modern agriculture. This long-term exposure suggests a natural adaptation to gluten-containing foods. The presence of gluten-degrading enzymes in our digestive systems is not coincidental but a result of evolutionary necessity. This ancient relationship reveals that gluten is not inherently harmful but a testament to human adaptability. For most of us, gluten is just another protein, seamlessly integrated into our complex dietary heritage.